Hello everyone. Today we will practice with probability density function of continuous distributions. So here's the question. If the joint probability density function of x and y is given by, so this is the way we can show the joint probability density function based on two variables. Both of them are continuous random variables, x and y. So it is equal to 24 times xy, 4, and these are the limitations as we call them domain of this function. And in elsewhere we will consider it 0. It means that the probability for them elsewhere is equal to 0. So this is the domain that we should consider so that we will have such a function. So before going through these questions that I will explain one by one, let me talk about the domain here. So whenever you receive a domain, it's nice that you specify which area that we are talking about. So it depends on x and y, two variables. So we will have two-dimensional case. And here in this limitation that you have, it means that both x and y are there. So in order to show it on the graph, let's consider the limitations one by one. So the first limitation is that x is between 0 and 1. So if this one is x-axis and this one is y, then x is between 0 and 1. So that's your limitation. Okay, what about next one? So it means that this is related to intersection of limitations. So all of them at the same time should happen. But first, let's consider this one. 0 and 1. So y is between 0 and 1. And they are not also inclusive case, not equal for y more than 0 and y less than 1. It doesn't matter. Why is that? Because we are talking about continuous distributions. Okay, so in case of a density function for continuous random variables, it doesn't matter whether I consider them equal or not. So we won't be sensitive about this part. But if we are talking about Poisson or binomial distributions, they are discrete ones. So we should be careful about equality for those cases. Now, y between 0 and 1. Let's consider this one as 1. So the new limitation is this. And what's the intersection? The intersection is here. But we have another limitation. X plus y less than 1. X plus y should be less than 1 at the same time. In order to show it on our graph, it's better to first consider the equality bar to find the line. Then based on the line, we can see that which part of the line we are talking about based on this inequality. So if I consider x plus y equal to 1, I can show it like this. And we are talking about this line. Okay, so you may ask me, how do I understand we are talking about the area over this line or below? So in order to check that, it's easy because you can, for example, consider a point here and to check whether this point satisfies this inequality or not. If it satisfies, it means that we are talking about this area under the line. Otherwise, we are talking about this part. So this point, for example, let's say this is x1/2 and y is 0. So I'm considering this point, y/2 and y 0. And I put it inside this inequality to check whether it satisfies it or not. So x is equal to 1/2 plus 0 less than 1. Is it true? Yes. 1/2 is less than 1. So I understood that this point should be here in this area. And that's why I consider the area under the line, not over it. So here neatly is shown that this is the domain that we are looking for 24 times xy. And this is the formula of this equation. So this linear equation that you can see is shown here, and x can be maximum 1, y can be maximum 1. And we are talking about this area. Why this is important? Because when you want to calculate marginal probabilities or even any calculations related to probabilities of joint distributions, we need to understand which part of the curve we are looking for and how we can limit it in the domain. And based on the domain, you can define your integrals. So when you say minus infinity to infinity, then which part of it are you considering for your integral? And something that usually students tend to have mistakes is related to, for example, this graph that we are showing here. It's not fxy. Be careful. Fxy is equal to 24 times x and y. And this is only in this domain, okay? So this picture that we see here is related to the domain, not to the function. Otherwise, the area under this curve is 1/2, not 1. And why this is important, that area under the curve to be 1 for PDF. We explained it before that for cumulative case, when you consider all the possibilities from minus infinity to infinity, it should be equal to 1. So we want to prove that fxy is a joint probability density function. So for this function to be joint probability density function, we should show that from minus infinity to infinity, this should be equal to 1. So as you can see, from minus infinity to infinity for both x and y, you see, for both x and y, because we are talking about two-dimensional case. So let me show you the details for getting integral in details here, but for the rest of them, for the rest of the questions that I will show you, I won't go through the details that much. I will show you mostly about the boundaries, because the boundaries are the most important, and based on which variable we are trying to get these integrals. Otherwise, the calculations should be easy for you, as you know about calculus. So if you don't remember about double integrals, please go through your calculus course once again. But note that the problems that I will give you for double integrals, they are easy. It doesn't need such complicated calculations for double integral. So mostly I will give you polynomial case, which is very easy to calculate for integral. Okay, so here let's see what we are doing. fxy, this is equal to 24 times xy. So 24, I can get the constant out of the integral. So I get the constant out, and here we have x and y, dy dx. You may ask me, does it matter whether I consider dy before dx or dx before dy? No, it doesn't matter, but we should be careful about the boundaries that you show here. If you, for example, consider dy here, it means that this integral is related to dy, okay? So this integral is based on y, and the other integral that you can see here is based on x. So we should be careful about specifying these boundaries. So how did I figure out the boundaries? So this part is related to x. X can be between 0 and 1. Okay, so first we fix it on constant numbers. The next thing to do, the next variable that you will consider should be either, if we mention about, for example, x and y in the same like inequality here, then the next one for sure should be based on variables. But if I didn't have this part, then I could just consider it between 0 and 1. But here is not the case. Here we have another limitation that we should consider for our domain. So from 0 to 1 minus x because of this. What does it mean? It means that for x, I consider it from 0 and 1. Now, when I want to calculate it, I consider it from starting from 0 to this line. Okay, it doesn't go necessarily to 1 all the time because of these lines, as you can see. So this is usually tricky, and you should practice a lot with different examples. That's why I suggest you to go through the book. Also, if you need more, go through even other sources to find the similar examples. In the course syllabus, I mentioned about other books that you can look for. And in those books, you can find similar examples. That's why I suggest you guys to just go through them, especially the ones with solution, so that you will practice with them. But today I'm going through one of them in details for all the possible questions that we can ask you related to probability density function for random variables in case of continuous random variables, of course. So here we ask you prove that fxy is a joint probability density function, and here we should consider all the possibilities, and I know that this function is equal to 24 times x and y only in this domain. Okay, so first I calculate this part. So it is based on y. It means that x now can be treated like a constant. So y power 2 over 2. And since we have given you the boundaries, you can calculate it one by one. So you insert this one instead of y. So 1 minus x power 2 over 2 minus, then consider 0, assign 0 for y. So it will be 0 over 2 multiply x, which is the whole thing, 0. So it will be the last one. If you don't remember about such things, how to calculate the integrals, please go through calculus course. It's very easy, and we are not going to evaluate you for getting integrals for complicated ones. So I will ask you such easy questions like using polynomial and get the integral from them. And now that we have everything based on x, I can calculate this part. So now based on x, you can calculate this integral, and you will see that the final answer will be equal to 1. So from here, I understood that fxy is a joint PDF, probability density function. Okay. The other question that we can ask you is about probabilities based on the given function. So here, if we ask you what's the probability that x plus y is less than 1 over 2, you have both x and y for this probability. It means that we should look in fxy in order to find the answer. So we need to get double integral again, f x y dy and dx. Now the limitation is changed. We have another limitation that we should take into the account, and we consider it for finding the domain. So in the picture, Now we have another limitation, and this is x plus y to be less than 1 over 2. Now we are talking about this area, okay? So based on this area, again, when we are talking about double integral, I should be careful. One of them I consider for x to be just constant number, which is 0 and 1. You see, I'm considering dx here, okay, for the first integral. The second one, now I have a limitation which considers both x and y. So for that one, I should consider it not all constant. So starting from 0, how do I know I should start from 0? Because here I know that y cannot be a negative number, right? Everything that's why it starts from 0. It's not always. You should be careful. So for the upper bound for the second integral, x plus y should be less than 1 over 2. That's why everything is based on y, correct? So 1 over 2 minus x, that's my upper bound. So maximum y can be equal to 1 over 2 minus x. So the next thing to do is to consider 24xy here, like the previous slide, and solve this double integral and find the final answer. In the exams, what we are looking for and what we are evaluating is related to these boundaries, how you define them, which is very important, and also your final answer. Okay, so the calculations between them is not interesting for evaluating your answers, but if you provide, why not? This is not compulsory, but it's good that you provide. But these are the parts which are very important. So this part and the final answer that you should provide accurately. Okay, what about this one? Probability of x plus y exactly equal to 1 over 2. Exactly equal. When we are talking about continuous random variables and this density function related to them, of course, this one is equal to 0. You don't even need to go further and find the domain and everything. So we are talking about a line under the curve. So obviously this is 0. If you want to find the probability, it should be in terms of area. Like, for example, when you have 1 here, 1. So if you are talking about area under this curve, of course I can find the probability. But if you talk about only a line like this, then of course a line over infinite number of lines here is almost 0. So directly you can say that. What about this one? Probability of x plus y more than 3. Is it even possible? You see, x can be maximum 1 and y can be maximum 1 based on the limitations that we define here. You see, maximum 1, maximum 1. So maximum, they can be 2. And it's not possible to be more than 3. So right away, you can say this is equal to 0. As you can see, it's very important from the beginning to show yourself what is the domain. If you understand about this part, to calculate the rest will be exactly the same like other examples. This part is tricky, and that's why it needs practice. If you think this is easy just because I've given you the solution, that would be underestimating this question, because of course this is easy, but as soon as you see the solution, if I give you other functions, can you find the domain correctly? So please practice with them, and this is very crucial in order to do that. Okay, what about next question? Marginal PDF of x. So I'm asking you about fx. How to calculate marginal PDF of x when you have joint PDF. So this one is given to you, you already have it, but how to find the marginal PDF of X? In that case, you should get integral based on Y. And we explained in the lecture why we do that. When we talk about fx, you should calculate it based on Y. If you are trying to find marginal PDF of Y, then based on X you should find. So what should I write here? It should be the joint density function which I have. And here, what should I write? This one is important to take notice here. For dy, so everything is based on y. And for y, I know that if you want to calculate it for x, you should consider from 0, everything starts from 0. Then here for my upper bound, I should be careful. It's not equal to 1. And this one is equal to, this one has another limitation for both x and y. You see, x plus y less than 1. That's why if there is such a case, I should be careful. So that's why, based on y, I understood that I should consider 1 minus x here, you see. And here to write what is exactly fxy, it is 24 times xy dy, and then you find the final answer. So I'm not going to show the details related to calculations because it is related to calculus. Please go through that if you have any problem with it. So what about marginal PDF of y? So I'm looking for y now. It means that I have xy, the joint probability distribution function. I mean probability density function because we are talking about continuous random variables. So here, in order to find it, I should get integral based on x. I consider fxy, I directly write it here. So first, like previous slide, write this one, then make it equal to, then assign the variables. But here I directly wrote it because we assume that you know it now. But for your exams, please start it from this part so that we see that what we are talking about. Okay, so for x, we know that the lower bound should be 0. Here, again, we can have a limitation for x. So if x plus y is less than 1, and everything should be based on x, so you bring y to the other side, and here you should have 1 minus y here. See, guys, we should be careful about these boundary points. Whenever the limitations are only about x and y itself, I mean, we don't have this part. Assume that you don't have this part. Then it's very easy. All the time you can use 0 and 1 because x and y are independent. But usually in our problems, we are dealing with x and y together for one limitation. Otherwise, it would be too easy. So here you will find the final answer, and you will find marginal PDF of y. And we can also ask you questions like, are fx and fy independent? Do you remember how to do that? So xy, is it equal to what? Can you remember? Fx, fy. So if you have calculated fx and fy from the previous slides, this one and this one, then it's easy to check this part because this part is 24 multiply xy, and these parts are already calculated by you. Find the multiplication of them and check whether this is equal to the joint PDF or not. If it is equal, then you would say yes, they are independent. Fx and Fy are independent. But if they are not equal, then you say no, they are not independent or they are dependent. Okay, assume that we have given you x, y, the joint PDF, and we ask you such questions like, what's the probability of x less than 1/2? So here you can see that we ask you only for one variable. In the previous questions, like this one, both x and y were there. So here we have only one x. It means that you should find fx in order to find the answer, okay? Otherwise, you need more calculations and maybe it could be confusing. Of course, directly from the joint distribution, you can do it, but again, you should be careful about the boundaries. But assume that you have fx, then this is easy to calculate. Now, since you have already calculated fx, then you can get the integral for fx, and here we have dx, okay? Here we have dx, and here for the boundaries. So we know that x starts from 0, and here the limitation, we have a new limitation. It says that it should be less than 1/2, okay? So based on this, you can find the final answer. This answer that you will find should be a probability. It should be a value between 0 and 1. And that's why those students who ask me why here you don't consider, for example, 1 minus y or something like that, it's because at the end you need to find the probability. It's easy to check. So if you find something else, it means that you have chosen your boundary by mistake. But here, as you can see, this is our limitation, not related to another variable. But here we have another variable, and also here. That's why we needed to apply double integral, and one of them was related to another variable. So these things need practice, guys. For sure, it needs practice, otherwise it could be confusing. What about probability of x equal to 1/2? Whenever you see equality for our questions for continuous random variables, you should be very happy because right away it's equal to 0. Very easy to deal with them. We already talked about it before and why this is the case. All right, what about expected value of x? So we have already talked about it in the lectures that we should use this formula. Okay, so for ex, we need to consider also x multiply fx dx. And what is the boundary? So for boundary, we should be careful, guys. Here, what we will find will be a constant at the end, because we are talking about the expected value of x. So what you will have should be between 0 and 1. So we had 3 limitations for our joint distributions, right? These 3 limitations. So directly, if I ask you what is ex, then what should you do? You should first of all find fx, marginal density function for x only, and x is just a variable, and here the boundaries are tricky. Now we don't consider this part. Why is that? Because we are talking about expected value. This one should be at the end a constant. And here the only thing I have related to constant is that x is between 0 and 1. So the rest is easy to calculate. As soon as you find fx, just assign it to fx, and the rest is easy to calculate. For expected value of EY, again, we have the same. So instead of X, now we have Y. Here we have Y based on Y, and boundaries again from 0 to 1. So we don't consider 1 minus X here again. I've told you why. Okay, let's go through the next item. Variance of X. Do you remember the formula related to variance of X? It should be expected value for X power 2 minus power 2 of EX. You can also show this one like EX power 2. So EX you have already calculated from here. You know how to calculate. So if I want to find the variance at the end, I need to know how to calculate this one. So again, you know why the boundaries are between 0 and 1. Here, instead of X, I have X2, Fx, dx. That's it. You can find the final answer. So by assigning this value for Ex power 2 minus E power 2x, you can find the final answer. Good. For variance of y, of course, you should do the same. And for covariance of x and y, do you remember the formula? Expected value for xy minus multiplication of expected value of x, expected value of y. So these two, you already know how to deal with them. You already know how to calculate. But what about this one? This one can be tricky because it has both x and y inside. So here I need to get double integral because of this, because it has both of them. So x, y, whatever you see as arguments inside the expected value, you can consider it before the function. So I need to use joint PDF here. And it should be again based on dy and dx. You see? So I should consider that part. And for finding the covariance, 0, 1, 0, 1 minus x. Okay, again, you should consider this part because x and y, both of them are there. We know that there is a limitation based on both of them. That's why we need to consider this one. You may ask me, oh, we are looking for a constant at the end, but you have a variable here. No, there's not a problem because first you are calculating this part, this integral, and the last one is based on constant. That's why the final answer that you will find is based on constant. You may tell me, this is very similar when you asked us this question, whether fxy is a joint probability density function. So what's the difference? As you can see here, we consider fxy without any variables before it. Otherwise, it will be always equal to 1. But here you can see we have a multiplication of xy before it, and it can change everything. Okay? So the final answer would be different from 1. And here you should consider 24xy, and you have 24x power 2, y power 2, and you will calculate a different function now. That's why you will get a different answer. Sometimes it could be equal to 1 by accident, but not necessarily. Okay, for correlation of x and y, which is very important because for most of the practical questions that we are asking is related to find the relation between x and y, how they are related. So we should know about the formula related to correlation. You can also show it by rho. Rho is equal to covariance of x and y over square root of variance of x, variance of y. So I have already shown you how to deal with each part of it. You know how to calculate covariance from the previous slide. So this part is EXY, and when you calculate this one, then by considering the whole thing here, then you will find the covariance at the end. Sometimes you may get excited as soon as you find this one and you forget to provide the final answer for covariance. Be careful that at the end you should calculate this formula. Here I just shown you expected value of x and y. The same I could say about variance. Sometimes you calculate for this part, you forget to provide the final answer for the whole equation. Okay, so for rho, I told you that this is equal to this formula, and you already know how to calculate covariance of x and y. You know how to calculate variance of x, variance of y separately, and provide the final answer. The thing you should be careful about for your final answer is that it should be a value between -1 and 1. Okay, so if you find negative values, don't worry, it can happen because covariance could be negative. You see, here based on this formula, it has EXY and it could be any value. Of course, for EX and EY, we could say the same, but for variance, always you will get a value, a positive value for sure. But for EX and EY and the multiplication of them, you can get any values. Okay, guys, for this one, as you can see, if we ask you even a simple question like find marginal density function, it could be time consuming to deal with that. And for the exam, we are asking you such questions. So they are very easy, but it needs practice for sure. If you just study the lectures at very close to the final exam or midterm exam, that's the problem, because you didn't have enough time to practice, and you will have problem with the duration of the exam. And duration of the exam most probably will be 3 hours for both midterm and final exam. So you guys should practice with it so that you will have easier time for your exams. Otherwise, the questions will be easy. Okay, guys, if you have any questions, you can participate in the online office hour, or you can send me emails to ask your questions. See you guys.